All right, class, we are on page 1 of your new packet about solving equations. And the first section is solving systems of equations by graphing. What I want to first point out is that we have 3 different systems here, 1, 2, and 3. And I want to demonstrate how there can be 3 different types of solutions when you have 2 lines graphed. So for the first one, I'm going to graph this one in green. It crosses, they're both in slope-intercept form, so I should be able to graph these fairly easy. First one crosses at 5, goes up 1 and over 2. There's a slope of 1/2. So I can graph that quick. The second line crosses at 8, but it has the same slope. It goes up 1 and over 2, or down 1 and left 2. Now, when we're talking about the solution of a system, we want a common point between the 2 lines, or an x and a y that works for both equations, the top and the bottom of the equation. And as you can see, I do not have a common point. And I'm never going to have a common point because these 2 lines are parallel. So our solution is no solution, or it's undefined. Okay. The second one, which I'll do in red. Okay. First one crosses at 0, has a slope of -2 to 1. So it's down 2 and right 1. I can go up 2 and left. So there's your first equation. The second equation crosses at, has an intercept of -6, and it has a slope of 1, up 1 over 1, 1-to-1 slope. Okay, this system looks like it has 1 point in common. Alright, it happens to be right there. Okay, so individually each line has an infinite number of solutions. This line going down has as many dots as you want to put there. Alright, same thing with this one. This has an infinitely many solutions. But together they only have 1 common solution. And that point is the point 2, -4. So our solution here is the point 2, -4. So this one had no solutions. This one has 1 solution. Alright, last but not least, I'll do this one in black. Okay, you notice that this equation here is not set up y equals. So it's not as easy to graph, but if I remember my intercept method, if I plug in 0 for x, I get 2 for y. If I plug in 0 for y, I get 3 for x. So that's just one easy way. Or you could take this and you could put it in slope-intercept form, which is actually pretty powerful. It tells us a lot. So if I subtract 2x from both sides, left with 3y equals 6 minus 2x. Divide by 3. I'm going to rewrite it -2/3 x plus 2. What you notice is that when I put this in y equals, I get the same thing as my second equation. So when I go to graph this thing, this one crosses at 2, but so does this one. So I have a y-intercept at 2, and I have a slope of negative 2/3, down 2 over 3. So that's the case for this one. Crosses at 2, goes down 2 and over 3. Same thing here. This crosses at 2, crosses the y-intercept at 2, and goes down 2 and over 3. So these happen to be the same line. Even though at the beginning they didn't look like they were the same, they are. So essentially we have a system where we have two lines that are the same. One line has an infinite number of solutions. So the solution for this, you can say infinitely many solutions. Those are the three possibilities. You can have no solution, one solution, or infinitely many.